All right, excited to see all of you back. Welcome to the final keynote of today. And we're welcoming Willem Hubrechts by 51N4E. So welcome, Willem. 51N4E is an architectural organization, you could call it, from Brussels, which calls itself a self-steering collective that advocates collaborative design culture. As INDESEM, we obviously support this collaborative design culture, as we want to practice this ourselves in this week of alternative education. Willem studied at KU Leuven, where he graduated in 2019. So just like Manuel Buzas earlier, we have once again a young leading architect on the stage. He has been one of the key figures of RECAST, which is a platform between architects, engineers, and consultants, founded by 51N4E and gineers. Which means also in this practice, collaboration is key, and they try to find value and connection in this process. They call it an interdisciplinary dialogue between everyone that's in the practice of building and bringing transformation to a larger scale. We're very happy you are here, Willem. The stage is yours.
Thank you. Thank you for the introduction and for the invitation. I'm just a messenger. I'm one person of a group of 85 people, and I will do my best to represent 51N4E here today. Question we get a lot is, what does the name mean, 51N4E? Well, maybe this explains it. It's 51 degrees north for east, so the location of Brussels in the world. That's also where our practice is located. Our office is in the center of the northern quarter of Brussels. I don't know if you've ever been there, but if you arrive through the North Station in Brussels, you end up in a very schizophrenic world in between a large business district that was built in the 70s and one of the poorest neighborhoods, communes of Belgium, in between corporate worlds and the poorest region of Belgium. And then in the middle there is a station, and in the station we have our office in the former train museum, which is quite exciting. We rent it from the NMBS, the Belgian Railways, and it's partly our offices, but half of it, of the square meters, we rent out. One of these spaces is this double-height mezzanine space, which used to be the central location of the first locomotive of Belgium, and now we rent it out to both as an event space to both organizations in the northern quarter, so social organizations, but also more corporate events, sort of trying to mix the two and be a sort of active, take an active role in our context. I would try today to talk about 3 projects which work around the theme of obsolete buildings, and then talk about RECAST, a sort of first introduction of RECAST to the world. This is the first building. It's the World Trade Center in Brussels, which was sort of, it's not there anymore. It's an old picture. Very efficient, almost Miesian tower, or group of 2 towers, which is part of a sort of bigger plan that was made in the 60s, a post-war modernism, optimism, where Brussels would become the center of Europe, big roads, highways crossing through the northern quarter, creating a sort of car-based partly helicopter oriented building site, which of course doesn't work. But this was the sort of breeding ground of these two buildings. And this is an old picture that was taken, I think, in the beginning of the 70s, where you see the huge demolition that happened in the northern part of Brussels in order to build this business district, sort of the Manhattan of Brussels, creating a sort of scar in the urban tissue that is still there and that still reads a sort of problematic part of Brussels. And in this context, these two buildings were there. They were vacant, considered end of life. The structure itself was too thin. It was a steel structure, so the buildings, the columns and the slabs around are steel columns, so they were not fireproof. And the client or the owner of this building organized a design competition to know what to do with this site. And almost all the competitors got rid of it. They demolished it. And 51 M4E came with this solution to keep actually the cores of the building, so the two central cores, and the whole foundation, so everything that is underground is kept. And on top of this existing grid of columns, we rebuilt a sort of new structure around these two cores. But instead of rebuilding the two towers as separate towers, the idea was to build a third volume, the volume capable, the capable volume, which is a tower of 2-story high stories. So it's skipped every floor, resulting in this moment in the demolition. So the building around the core was demolished. We tried to recover as much of the materials as possible, but the cores were still there. And then the idea was to maximize the square meters around these two cores, but keeping as much of the concrete and the CO2 that was embedded in this structure as possible. And this is the sort of the two sections that you get. Of course, if you keep the core and you keep the stairs, you have to keep the height of the spaces, which was actually too low for the Codex Welsen, which is sort of a comfort level that you need to get for a workspace. So we couldn't get the 2.70 meters that was required for the Flemish government to enter the building. That was the idea. The client wanted to have one big renter for this entire tower. That was one problem, and the second problem was that the Flemish government, so it's the government of one part of Belgium, they didn't want to work in towers because they wanted to have a sort of horizontal collaboration flow. And by gluing the two towers together, you get these very big floors of more than 3,000 square meters of floor area. So all the odd numbers of floors had this plan where you had a sort of connection between the two cores. And another ambition was to make it a hybrid building, so not making the same mistake as the past and creating this monofunctional neighborhood, but to combine housing, hotel function, commercial spaces. And instead of making separate buildings for these functions, the idea was to take all the odd floors, so the even floors were for the Flemish government, and the odd floors were housing and hotel space. So you end up in this, what we call the zebra model, which is a sort of hybrid building, but it's still one building. And this is the type of spaces that you get by having these super high floors. And the idea is that because of the double height, you get the light way deeper in the building, which makes it possible to have workstations in the middle of the building. Because normally you can only have your desk quite close to the window because the light needs to enter. And the further you go from the window, the less light enters, and there is a regulation that doesn't allow you to put workstations there, but because of this height, we could make this entire floor actually primary floor area. And then in the two towers, so the lower floors were this meeting center where no one would have sort of permanent workspace. So the height of 260 was not a problem. 270 was not a problem anymore. Then you have this big entrance lobby that sort of is this volume capable in between the two cores, organizing the flows. Yeah, this is a heavy PDF, apparently. Something's happening. Yeah, while waiting, I can maybe explain. So the stair, this main stair, so when you come in, the idea is to enter the building. Okay, let's ignore this. Okay, restart. Well, let's skip the plan. Voilà. The idea is to enter in a big stair that takes you to the first level. So the elevator shafts are actually for the office spaces are on the first floor, and the ground floor is actually the entrances for the housing and the hotel. So the same shafts of elevators can be used for both programs, but they never cross. So this was a solution to keep the existing elevators in the tower, but still organizing it in a way that you don't get interference of safety, so that people of the housing don't enter the office space and so on. And that's the result. So the volume capable has a sort of different architecture, and the two towers, the existing towers, refer to the former Miesian architecture. And of course, on the ground floor, in between the two empty spots, this is a competition model. The idea was to make public space, which is not used by the three, or could be used by three of them, but is not exclusively space for them alone. So in between the two volumes, there is this greenhouse. In Brussels, there is a regulation in this area that you need to provide 10 square meters, 10% of the footprint for green area. But because of these high towers, the quality of this green space is quite low because there is super high wind velocities. So if you're constantly in the wind, nobody actually uses the space. So we came up with the idea to make this big greenhouse touching all of the different programs, but which can also be used as sort of event space, a bit like this space we're here, which is connected to both the hotel and the office space. Of course, because the building was made for the Flemish government, which had a very high ambition considering reuse and reuse of materials, we had the sort of leverage to convince the client to investigate all of this reuse of materials. And one of the biggest impact we made by reusing the existing structure, which is almost 50%. So this flow diagram is sort of the weight of all the materials that were in the existing buildings, the ones that are reused on site, reused somewhere else, and so on. But 60% of the weight of the building is actually reused just by reusing the cores and the whole parking building underneath. Of course, there are other materials that we try to reuse as well. So the washed concrete tiles that were used on the deck. These convector bakken, like the convector structure, sort of reuse. We did this together with Rotor, which is a Brussels organization that really focuses on salvaging these materials and reusing them and selling them in their space. The concrete that was sort of drilled out of which was the top floor of the steel structure, was reused in the new concrete that was for the new structure. So that's the first project. Another tower, actually it's right behind is the World Trade Center. This is Victoria Tower, which used to be IBM office space. So the American IBM, they had this tradition of building these very nice, slick, well-detailed buildings, and this is one of them. And before our clients bought this building, there were other developers that tried to renovate it, resulting in these sort of crazy, almost pastiche projects. But when the client came to us, so this didn't happen. When the client came to us, we sort of tried to embrace the quality of these very simple stylistic facades and try to see the qualities of this rhythm of spaces, of windows inside. We made this mock-up to sort of test living qualities in this building, and this is what it ended up with. So we added we made the lines a bit higher, so the top floor became a roof terrace, and on the ground floor the building was not landing. So if you, I don't know if you can see it in these buildings. These buildings were designed to enter by car and then take the elevator up. So there is no relation between the street and the building. So that's a sort of detail that we added on the bottom. And the client, again, so here the idea was to reuse as much of the structure as possible. So only interfering where it's really necessary. For example, these ventilation boxes that were in the on top of the windows, we took them out to clean it up, and then of course we had to add insulation to get to the current norms for heating. But the facades as a sort of system was kept. We didn't reuse the material itself, which wasn't possible. But this is sort of test that we did to convince the client that it shouldn't only be office building, but it could also be a co-working, which of course is also office space, but also hotel. So in the end, the building again has a mixed function. So it's on the top, it's a hotel. Middle zone is like offices, and then 5 floors of co-working. And the thing that we really had to design in this building, because we're just keeping it as it is how you enter and how these flows of people are organized. And the idea was to, or that's also what happened, is that the hotel, since the building is connected to a park around, goes down into a double height space where there is the hotel lobby. But the office spaces, you go up, and then there is we call it the piano nobile, the first floor, which has a double height space, which creates a sort of central space in the building, which is the rest of it is just the normal slabs, but this creates sort of a moment where you get air into the building, resulting in this, the 3 interventions: the roof terrace, the piano nobile, and the new canopy entrance. That's the design. This is a picture when it was a sort of poetic moment before it got redressed. And then the third project is this Recypark. I saw the picture on the wall there, so I think somebody knows this project already. Here, this is a Recypark, so it's a recycling park, quite close to the center of Brussels. So It's not on the edge of the city, but quite in the center. And the client came with this triangular plot. So the client is the city of Brussels. And they said, okay, we want to have a recycling park. There was a design competition. And actually, the plot was too big for only recycling park functions. So we could actually condense the functions in this smaller edge. And then there was a sort of leftover space. And the idea was to combine, since it's in the center of the city, to make it really a public building, combining the Recypark functions, which is during the day, to also other functions. And again, we worked together with Rotor, which has a sort of, they had a catalog of existing wooden structures that were soon to be demolished, and they sort of inventorized them. And in the design competition, we made sort of several propositions of adding a sort of roof on the Recypark. We didn't know yet which one it would be, but this roof would provide a sort of covered space in the center of the city, allowing for events to happen or different functions. And in the end, yeah, we won the competition. And the program that got selected was a skate park, which is a covered skate park, which didn't exist yet in Brussels. So, and then the tricky part was to get this wooden structure from somewhere else. So in the end, the structure was reused from somewhere in Liège, so 1 hour drive, a former horse driving manege, which was built in the 70s, I think. And then we decided, okay, we're gonna move it, rebuild it there, and use it as a structure for the roof. But this was quite complex in a way, because reusing structures is not as straightforward as you might think, because we didn't know the quality of these woods. We didn't know the how it was made, what kind of glue was used. So in order for the structural engineer to allow us to build this, we needed to do a lot of destructive testing. So actually a large part of the beams were demolished or were destructed by testing it. So you break them, and then you know, okay, that's the maximum, that's the highest pressure we can get on this building. So the structural engineer knew what to reuse. And actually, because they have to add a lot of extra safety measures, they had to combine the two beams together to get the right strength. And only the double used beams are the one that we reused, and the new ones are these that we had to add because we were losing so many of the trusses. Here you can see, so in the back are the new, the existing ones, and in the front here is a new one. So reusing structures, the legislative framework is not there yet to do this. So there is no insurance company that says, okay, it's fine to do it like this. So there is still quite a long way ahead to make this financially feasible, because it was a nightmare for the company, because we had to put so much time in this. Of course, we like to do this, so it's not that much of a problem. Okay, so now I want to talk about RECAST. As you explained, it's a new studio within 51, which is a collaboration between us and gineers, which is an engineering company. And as you saw in the previous projects, a lot of the constraints that we meet by reusing structures or reusing infrastructure is a quite technical, of quite technical nature. So combining engineering and architecture, like space design and technical design in one team was sort of self-evident. And I don't know how this works in the Netherlands, but in Belgium, this is quite, there are two worlds that sort of work together haphazardly, but never in an integrated team. So the idea was, if we combine our forces and we sort of have an integrated approach, we can scale up the reuse of these buildings just because of the methodologies that we build together and that we can use quite fast and in a scalable way. So the idea of RECAST is to repurpose existing buildings with the maximum reuse to provide a realistic solution for Europe's 2050 ambitions. Because the idea of Europe is to go net zero in 2050, which is in 25 years. But in order to do that, we need to renovate a huge amount of buildings. Like, it's crazy. But at the same time, we don't have the industry to do this. So I made a quick calculation. The Flemish government did a sort of, and they had from Europe, they had to do a sort of calculation on how much money it would cost to renovate their entire building stock. And they said, okay, it would be around 200 billion euros. If you invest this, so this was in 2020, if you invest this in 30 years, every year 1/30 of this 200 billion, you would need a building industry in Flanders that has to be 44% bigger than it is now. So we don't have the money, but we don't have the people to spend it to either. So this ambition is super important. It's where we have to go to in order to reduce our carbon emissions. But if we don't do it well, and we spend every euro that is spent is a euro that has to be spent well, because otherwise we're increasing this light blue bar even more. So that's one thing. And a second observation that we made was that we took the Stadbel data, so the statistics of Belgium, and we looked at all the cubic meters of buildings that is being demolished every year, divided in residential and non-residential. So this is every year demolished, and this is what is being built new. Of course, sometimes you need to demolish in order to build. But if you look at the percentage of buildings, of building volume that is being demolished, 94% of it is non-residential. And what we see is that a lot of the regulation around sustainability is focused a lot on residential policies, because it has a big impact politically, I don't know. But we saw that like not demolishing non-residential buildings is a huge opportunity to reduce these cubic meters of newly built every year, emitting a lot of CO2, of course, in order to build these buildings. So that's sort of the backdrop against which we sort of were convinced that we had to do something. And the first study that we did was a study for this building. It was a second opinion study for the Brussels city architect, Brusselse bouwmeester, which was also convinced of the same ideas as we saw here. And he said, okay, if you want to demolish a building that is bigger than 5,000 square meters, you have to make an argument why you want to demolish. And this building, the client or the developer, Gelamco, which is now going bankrupt, by the way, wanted to demolish this building in order to build a new building of the same size, but which was new and green and wood and so on. And they said, okay, but we cannot keep the existing building because there is this beam inside, which is too low, so we cannot put the ventilation in the structure, because the building was built in the 60s, renovated in the 90s, and was now being demolished. And they said, okay, if you want to add ventilation, which we need in order to get to the regulation of today, it's impossible because you have to cross this beam, and it's impossible. And also the ceiling height was too low. If you would have to add false floor, the ceiling height would become too low, and it's impossible to sell this type of building in the current market. And okay, so they made this list of arguments, and we got the time and the money to go through all these arguments and start to give counter arguments. For example, of course, there are solutions for reorganizing the ventilation in order to don't have to cross that beam. So we sort of came by design with solutions that sort of counter-argumented all of their arguments. And the building is still there, so let's hope that. And also Gelamco, they stopped the project, so they didn't buy it. And let's hope that this still works. And then that was the first time RECAST as a name, as a collaboration was coined. Second project, which is way bigger, is the center project. And I think it's interesting or important to understand that why this building becomes obsolete. It's a building in the center of Brussels, in the center of the European district. So there's a huge amount of office spaces, but the market for office spaces is decreasing because people work at home, especially in the European center. There are less expats because we can work from home digitally, and this market is shrinking. So the need to everyone wants to have the best building in the market in order for companies to attract them. So this building becomes obsolete because it's not the best top-notch building anymore, but it's a very good office building. That's not the problem. The problem is that it's not the best, and that's why they demolish it and sort of reuse it with the green sauce, or rebuild it with the green sauce on top. And that's this kind of project. So, which is completely different is this project, the center project. It's the last one I will show, which is the same client as the Victoria Tower that came to us, and they wanted to buy a portfolio of 22 buildings. Buildings that were built between the 70s and the 90s by the Belgian government for their tax offices. So they were located in small cities, not in big cities, small cities around Belgium, cities that don't have a market for office buildings. The buildings were sold in 2006 to a private investor, and they were leased back by the government as a sort of easy money trajectory by the government, but that's something else. And they were leased back with a contract of 20 years. 2006, we're now 2025, so these buildings are, the lease contracts end, and they will become vacant. And that's when the client bought them. And he bought them with the idea, we don't want to demolish them. So all the other developers who wanted to buy it wanted to buy these buildings for the parcel which it was built on in order to redevelop residential houses. But our client said, okay, we don't want to demolish it. We want to reactivate these buildings, even though it will probably not be an office building anymore. So these buildings become obsolete because of the function that they have, not unlike the previous project, because they're not top-notch anymore. But that's interesting because these buildings are sort of unique projects in their context. They're the biggest building of the town, oftentimes, and they're quite cheap. They're in good condition, which allows for example, schools, care facilities, social organizations that don't have a lot of money to sort of do the minimal intervention in these buildings and reactivate them, putting sort of new user inside, and try to make sure that they reuse the building for another 10, 20 years. So that's why we very enthusiastically said yes to this project. And because it's a portfolio of 22 buildings, we had to sort of come up with a strategy and organize ourselves, because how are we going to work on 22 buildings at the same time with a small team of engineers and architects and the client together? So we organized the atelier space, a central space where we work together 3 days in a week, the client, engineers, and the architects, in order to have a sort of short line and work together on all of these buildings together. And we made a sort of methodology consisting of 2 steps. First step is to do a complete analysis of the existing building. So what is the building as it is now? Not referring to older plans, but really look at the concrete that's being used, the techniques that are in there, the quality of the aluminum frames, the roof, what do we need to replace now, what is still in good condition. And by mapping these buildings, which is a huge work, but we knew exactly in what conditions these buildings were. So if we knew that there was a school that was interested in the building, then we knew, okay, you're gonna have to replace this and this and this, but these are in good condition, you don't have to touch it, so you can reduce the interventions that you need to do in the building. That's the first step. And then, so the first step is sort of looking back, what is the building, what happened in the past, and what is it now? And the second step was to guide the process of reactivating it. So giving it or trying to find a new horizon, a new future for the buildings. One example is this building in Halle, which is, again, a small commune in the center of Belgium, which had this site with 2 buildings, which was too big. So the Belgian government, they wanted to keep only one of the buildings. So they wanted to renovate one of them, and the other one was vacant. So we started a process going to the mayor, asking, okay, what type of program do you need? And in the end, we came up with a sort of combination, a campus with one of the top building is a separate building, which would be the Régie des Bâtiments, so the Belgian government's building, and the other one would become partly a primary school and partly a care campus. And because we had this knowledge of the building, we convinced the investor, which is a public investor, to buy the building, them being quite confident that they would be able to fit the program in there. And just by sort of facilitating this process without designing too much, only the things that we're trying to convince them of, what are the qualities of the building, we could extend the lifespan of this building, which is quite interesting approach as an architect, because you're not really designing too much. The second project is this one in Vilvoorde, which is quite similar building actually in sort of plan layout. It's a building that tries to look like a small house, but it's actually extruded in a big building of 8,000 square meters. And now we're having this process. In 2 days, we'll go have a sort of a plenary session with, I think, 15 organizations that are interested to be part of this new care campus, where the single organizations become a combination of childcare, medical center, all organizations that are linked in a way to care or integration, a school for volwassen onderwijs, like adult education. And because they are sort of in the same building and they have this one address in the center, there is an interesting ecosystem of care facilities that can exist in this building. So there is this old cafeteria that could become the buurtcafé or the bar that is sort of the central location in the building. And what you see, we're not designing with this building. The building is already built. You might like it or not. It's not the most interesting facade, to be honest. But we're sort of designing the use of this building and trying to convince the different care organizations to be part of this story, and trying to change the narrative of how you look at this building, which is sort of a second layer in architectural design. So instead of making a building for a user, we already have the building, and we're sort of trying to find the right user, which makes this obsolete building, again, a reused building which has a lot of qualities. And now I would like to dive a bit deeper in the numbers. So because we had this big portfolio project, the client allowed us to take a part of our time and dive a bit deeper in the sustainability qualities of what we're doing here. Of course, the client needs it as to sell the project, but for us it was super important because we wanted to know if what we are doing here, is it really better? Is it really better to keep this building, or just to demolish it and build something new with perfect insulation and a heat pump and everything else? So we got the time to dive a bit deeper into our projects. And one of the first things we realized, or we did, was to convince the client that if you want to look at sustainability of a building, you don't only have to look at operational energy, like EPB labels that is now a lot of focus on in our regulation, but also look at embodied carbon, so the full life cycle. If you want to build a building, you emit a lot of CO2 as well. So 28% of the total CO2 emissions, but numbers shift sometimes a little bit according to which source you take, but it's about 28%, and 11% is the total CO2 emissions of building materials. So if we're only looking at this 28% and organize policies that say, okay, we have to reduce our emissions from our heating and cooling and so on, it doesn't matter, don't look at the building materials. We might even increase this 11% and end up with a higher CO2 emission. So taking these two elements in the same consideration was key in our projects. So this is the project in Halle that we're renovating now. So as a section, the things that we're doing is quite limited. We keep the facade as it is. We replace the windows. We add ventilation. We put solar panels on top, put a heat pump. We put low temperature heating system, which works more efficiently. But we keep the structure and the facade as it is, which makes this building a building that is of the same comfort qualities as all the other buildings that are being built now, but it looks like a renovated building, of course. And then we did our calculations, and we made 4 scenarios. One, what if you don't do anything? What if you keep the building for another 60 years? What is the total CO2 emission? The light blue is operational carbon, so the CO2 that you emit by using the building. Heating is the biggest impact. And the dark blue is embodied carbon. So what do you need, what are you emitting in CO2 emissions for replacing windows after 30 years, renewing the floor, like these things that you have to do constantly, but you keep the building as it is. Of course, it's a lot of CO2, so we have to do something, that's clear. And then the 3 other scenarios are electrification. So what if we keep the building as it is, but we just put the heat pump instead of a gas fire, a gas stove, what's it called? Furnace, gas heating. What if you replace the gas heating by electrical heating? And then you see that it reduces the CO2 because the electricity in Belgium is quite clean because of the high percentage of how do you call it? Clean energy. Okay, never mind. And then, of course, we don't do anything, so we keep it as it is. Second part is the renovation. So we do replace the windows and the heating system and so on, but we keep the rest of the structure, which results in the lowest total CO2. And then there is, what if we would rebuild the building, insulate it perfectly, and rebuild the entire structure? Then we would end up with almost the same CO2 emissions if we would not do anything, but just replace it by electrification. So for us, this was already quite surprised that actually not doing anything is better than replacing a building, which is, according to our current standards, almost zero energy. It's actually the same. But then, what this doesn't tell you is when these CO2 emissions are emitted in time. And this is actually quite interesting, because if you build a new building, the CO2 will be emitted now. So the dark blue is CO2 emissions now. And then you can say, okay, but we emit a lot of CO2 now in order to reduce it in the future. So then this line becomes very flat. Electrification scenario is very low impact now. You just have to put a heat pump, which has quite some impact actually, and put some solar panels. And then because it uses more energy because you don't insulate extra and so on, in the end, the CO2 emissions is almost the same as a new building. Renovation is somewhere in between, so it has a medium carbon spike in the beginning and is sort of almost as flat as a new building. But what this doesn't take into account, yeah, and of course, if you don't do anything, it's a steep line. We don't talk about it. What this doesn't tell you is how, or what this doesn't take into account is the fact that there is an energy transitioning happening. So we are replacing gas-made electricity by renewables. So if you take this into account, and let's assume we believe Europe to go to net zero in 2050. That's the ambition. It also means that the electricity that you take from the electricity grid goes to net zero in 2050. So you actually, by electrifying a building, you absorb the sort of energy transition in your building, making this line go flat. And the electrification then ends up as the best scenario. We're not as good as the new building, we're even way better than the renovation. So what this means, or what I conclude out of this, is that we're now focusing so much on insulating our buildings that we're actually, and not focusing on this early carbon spike, that we forget that these buildings will absorb the entire energy transition inside. So we're wasting our energy. I don't know how this works in the Netherlands, but in Belgium, we're wasting our energy in demolishing and rebuilding green buildings that are actually in the highest scenario here, which, I mean, it's not only way more CO2, it costs a lot more money, it takes more energy, we need more hands on the brick than we need for a small renovation. So we're actually doing the opposite of what we should do. And the question is, why are we doing this? Why are we building new buildings instead of just remaking them? Because of course, if you build a new building, you increase the comfort. That's what I was talking about in the previous project. If you build a new building, you can build it like you want. So you can make the ceiling height high enough. You can make it look new, which is also important. So there is this, the comfort in this case is the trigger. That's the reason why we're doing it like we're doing it now. Acoustic, thermal comforts, air quality, heritage value. Of course, it's not a problem if you demolish. Accessibility is also quite an important one. Sometimes elevators are too expensive to build in existing buildings, so we just built a new one. But these comforts, what we try to do with RECAST is to always balance the increasing comforts to the cost that it has in CO2 and in euros. So, because, for example, all norms that make you change your building, norms in Codex Welzijn, for example. So the fact that the ceiling needs to be at least 2 meters 50 or 2 meters 60 or 70 reduces the things you can do with the building. So they're really imposing a sort of hard, deep renovation or demolition. And of course, this affordability, and that's something I said earlier, is key if we want to get to this 2050 goals of Europe. Because if you make one building, imagine you have 5 buildings. They're all in bad condition. And you take all your energy and all your money to renovate this or rebuild and demolish this one building to the best building, top notch, like we saw in the project by Gelamco. Then we don't have the money to spend on all the other buildings. So you can reduce one to the top notch, but all the others will still be there. If you renovate in a clever way, only do the things that you need to do, take into account that you need to increase the comfort to the maximum level, but not to the best, it's maybe not always necessary, then you can have a way bigger impact for the same cost. So what we try to do is to always weigh in this sort of triangle graph to weigh the increasing comfort. So the further you get from the center, the better. So this is lower CO2, lower cost, higher comfort. The dotted line is a renovation strategy where you say, okay, maybe we don't need to go to the best level of comfort, but we win in cost and climate. And that's a sort of graphical representation of the sort of balance that we always try to make here. And then as a conclusion, I showed, I think, 5 projects. What you see is that they're all completely different. So there is not one perfect renovation. It always depends on the client, the context, the quality of the building, what you can do with it. So renovation is a spectrum. And this allows also for different interpretations, or allows you to design with it. For example, Zin is 25% less CO2 than a normal benchmark building. Victoria, because we kept the entire structure, reduces 50% of the embodied carbon. And in Halle, it's almost 90. So, of course, the context was completely different. But as an architect or as a designer, you can try to sort of find your way in reducing this impact. Voilà, that was it.
Thank you, Willem. I'm standing here. I can imagine there are some questions. Thank you for your presentation. It's incredibly extensive and interesting.
Very great lecture. I have a question. Do you think Brussels is one of the leading cities in reuse and transformation because it's the capital of politics from Europe? And there the decisions get made about climate change and that kind of stuff?
No, I don't think so. I think what happened is I think there's a sort of coincidence that our city architect, the Brussels Bouwmeester, which is now, I think he did 10 years of it. He did 2 terms, and he was really involved in this reuse policy, and he really pushed it to the limits. And for example, the fact that you have to make this argumentation if you want to demolish it, the idea is, the standard is that you don't demolish. If you really want to, you need to come up with a good argument. And this sort of shifts the way we look at demolition of buildings. And I think sometimes it's these key figures that play a very important role. Because what we see if you talk about European regulation, and that's something I didn't talk about, but the buildings that we put on the markets, so we renovate them, and then the developer, he wants to make money out of it. So he sells the building to an investor, pension funds, insurance company, people who have a lot of money to invest. And what they look at is a very simplistic way of looking at what is a good building. And for them, these BREEAM levels, like sort of certification of what is good, is often also organized from Europe. So they are focusing with their EPB regulation a lot of this on this operational carbon, which is good because it was a first start in 20 years ago. But this now makes it very hard because these investors, they only look at this EPB level certificate, that we cannot put our markets for a good price because they say, yeah, but you're not, you don't have an EPC level A, EPB level, how do you call it here? In planners, it's EPC. So for the clients who does this project, it's very hard to sell this to their investors because the legislative framework, the regulation that are there, are actually sort of defining the discourse on what is sustainability. And it's changing now. So in Europe, there is now this idea that we should also look at the total global warming potential, like the total impact. It's changing, it takes some time. But for example, the EU taxonomy, which is a sort of complex new regulation that is sort of defining what is a good green investment and what is not, is only looking at this EPB level. So this instrument that is designed to organize or flush big amounts of money into green investments is looking at the Helamco projects more than at our renovations. And that's a big problem actually, because of course it will change, but it takes a lot of time.
Okay, thank you.
But that's a good question.
Hi, I have a question with the, with the two towers, and I think also the other towers with the long lines. So I did understand correct that you took all the facade off?
Yes.
And then you put it on again? Or I don't know if I missed maybe something, but, what is the reason behind it?
Yeah, good question. So, a lot of slides. No, we're crossing the PDF. Okay, so I will just say it like this. The problem was that the building had to be, it was not fireproof enough. So a steel structure can melt. That's what happened with the World Trade Towers, like the ones in New York. It was the heat that sort of melts the steel, which makes that it sort of collapse. So for high rises, it's a big problem. Of course, in the 70s, they didn't know this, or this was not a problem yet. But because they couldn't add a sort of insulation, fire insulation to the structure, which would be far too expensive and was really something the fire brigade didn't want, they had to demolish this part of the building. Or are you not talking about this?
No, I'm talking. Yeah.
And of course, if you demolish the thing that the facade is hanging on, you have to demolish the facade as well. Of course, for example, in these diagrams where you talk about reuse, the fact that aluminum is quite reusable because you sort of remelt it and it's considered as reused. Of course, this is not ideal. But sometimes other constraints push you or force you to demolish a part. And of course, and that's also, I think, important. For us, it's not sort of dogmatic approach on you cannot demolish anything. We know that it's better to keep it, but sometimes it's impossible. And if you really want to conserve what's there, resulting in a very bad building, which is something nobody wants, yeah, then in the end it will be demolished anyway. So you really have to, and again, this is the balance with the comforts. So you have to sort of try to reach an acceptable level of comfort, but within the idea that every CO2 that you emit now has a way bigger impact than what you would do in 25 years, because there is this huge energy transition, not only in energy, but also in the way we produce our aluminum. Aluminum in 25 years will be cleaner than the ones that we use now. So if you say that it's okay to use it, to do it now, because anyway we'll have to do it sometime, then actually it's better to sort of wait, and if some materials are still in a good condition, it's better to keep it. And especially aluminum has a very high impact in CO2 per weight, because it's super light, but also because it needs a lot of energy. Wait, am I answering your question?
Yeah,
okay.
thanks.
In collaborating with an engineering firm, how does that change the way you approach a project? How does it, yeah.
I will say how we normally work, but I don't know, because I know that in the Netherlands, the role of an architect is a bit different than in Belgium. But what we normally do, if you build a new building, is you design. You know a bit how a structure works, of course. You don't know exactly what type of rebar that you need to use or what type of concrete, but you know that there need to be columns, that they have a span of 7 something, and then that's a good distance, and then you need a new column. And then you design it, and then at a certain moment you start interacting with an engineering firm, and they sort of optimize it, and then there is sort of iterative process where you work together. So, but of course, if you work with an existing building, this is like the main information that you need. You need to know what is it. For example, if you don't know that you need to demolish half of the building and you start designing, then you're just wasting your time. So the fact that we need an engineer from the beginning is quite evident in reusing existing structures. But it's not only structural engineer, it also has to do with like how do you put ventilation in an existing building that doesn't have ventilation. Like all buildings, they didn't, we only started doing it in the 80s or in the 90s even. But now ventilation is like the main, like it's the first thing you have to think about when you're like reusing a building, because ceiling heights, it has an impact on ceiling height because you need to get, to put the ventilation duct somewhere. For example, in this building, you see these ducts everywhere, not here. Maybe there. Like here the building is quite quite large, so it allows for this space. But if the ceiling height is only 2.80 meters and you need to put 40 centimeters of ventilation duct, then it has quite an impact on the experience of space. So by doing it a lot, you sort of know what are the constraints that you have to work with. For example, if you want to add stairs for evacuation because the building was built before the current fire regulation, often you need to add stairs because of the distance that you need to evacuate. Then you need to know, can we make openings here? How does it work? Can we make an opening in the facade? How does a facade work? And then you need this engineer from the beginning. Yeah.
In your presentation, you had a lot of calculations, and I was wondering, as a student, how can we calculate the CO2 emission that our building or design causes?
Yeah. We work with a software which is one-click LCA. I don't know if it has a student license for this, but what it actually is, it's a big database of all materials that you can find in a building, and they put the CO2 emission per square meter, square units, whatever. And in the end, it's just an Excel where you say, okay, we have this amount of concrete, this amount of window frames, aluminum, we have walls of this type, and you just multiply it with the impact, and then you know what is the total CO2 emission. So what you actually need to know is you need to get access to this database, and often that's what you pay for. But in Belgium, there is a software which is called Totem. Maybe it's a free software, so you can. It also has a database, but it's way smaller. But it's because in Belgium they want to start making it compulsory to do this Totem analysis for buildings bigger than a certain size, if you want to get a permit or something. So they're trying to make it part of the permission culture in Belgium. That's why they're making it free, because otherwise, yeah. So
Okay,
maybe that's a good source.
So I have a question. Most of the calculations are done beforehand, right? But then after, do you also assess, for example, where or, for example, how much distance will your waste travel or the building wastes travel, and how much also, I guess, of CO2, but everything like around the waste after the renovation?
Yeah, so it's a thing. So in one click, you can also calculate the amount of waste, and it also takes into account the travel distance.
Yes, but for example, there are different materials and different materials that can be recycled within Europe or the Euro Delta, and there are different materials that cannot be recycled currently.
Yeah. It takes into account like the main standard of how it's being reused. You can change it if you know that you will reuse it somewhere else. So you can sort of reduce it to zero.
Ah, okay,
But
okay.
the problem is that there is no standard way of calculating this yet. So that's also why there is no regulation about it. So, I mean, there are some norms on how to do it, but it's quite fluent, and nobody really discloses on how they do this. So often what you see is calculations that are done, but mine maybe as well, where if you ask how they do it, you realize that it doesn't have any meaning, because they're doing it in a completely different way, or they're not taking into account. Or what they sometimes do is they say, yeah, but in 50 years, you will reuse this wooden beam. So you can, but wood is steel truss. You will reuse it. So we can take it into minus. We can say, okay, it will be reused. So actually, we don't have to count it. Of course, yeah, that's a gamble on what will happen in the future, a first thing. And the second thing, steel truss that will be made in 50 years will have a way lower impact than the one that you use now. So that's a sort of fraudulent approach, in my opinion. And for example, in the Gelamco argumentation, they said exactly that. So they were referring to, okay, but we will reuse all of this in 25 years. Of course, yeah, they're not the owner of the building anymore, so how can they be sure that this will happen?
So does Belgium has already some kind of material or waste material bank working on?
A waste material?
So, for example, materials that could be used again or repurposed or...
Nope.
Okay. Because like for the Netherlands, they did start a few of them, but of course they're not all established or they're not the fastest one. But I was wondering if Belgium also already have one.
Not that I know of.
Okay. Okay.
Okay. I want to thank you all for coming tonight. I think it was a very technical, extensive, sustainable discussion we've had. And it is incredibly important for the backdrop of this conference. We're closing the evening, but I would like students that will be traveling on Friday to gather for a last little circle in the front. I want to thank you, Willem Hubrechts, for this great lecture, and you all for coming and joining this INDESEM. Thank you.